Now the simplest model is that it made of the three particles. Two of these particles are inside the nucleus of the atom. You can imagine that it's like a solar system, and the other one is outside the nucleus. The two which are inside the nucleus are called protons and neutrons, and the other one which is hanging around outside the nucleus is called electrons. Electrons carries negative charge, and the protons carries a positive charge. Neutrons carries no charges, and the whole atoms in the normal condition, the number of the electrons and the number of the protons are the same, so atoms are electrically neutral. Now, since the name is astro, there are a lot of things that we need to prepare for doing the chemistry in the space, which we don't have such a technology. We didn't have such a technology for normal chemistry in the laboratory. For example, very simple example, sampling soil of the stones like asteroids at very, very low gravity. In the laboratory, we can pick up the sample very easy because of the gravity. But how do we do that when we are going to space? That is the simplest things that we have to do, and it is a big challenge to pick up a sample inside the space. Yes, but that would goes into the part of the universe that may not be interact with the light, and we know that it is called maybe the dark energy or dark matter, and that is a part that we have less information about them. The science of chemistry began when the measurements were taken into account for each experiment, and that was, we can say that it started from Lavoisier's work, which he started to measure the amounts of substance inside the chemical reaction. The only difference between the alchemy and the modern chemistry is about the measurements. Now, that is the idea which is following in one of the United States universities. The elements or even the material, number one should be very, very light, and number two should be very, very strong, and that seems to be the two properties with one of the carbon allotropes, which the nanotubes, they have such a property. So we can have, based on the theoretical and some part experimental data, we can have a very, very long tube of one layer atoms, like a tube goes up into the sky with hundreds kilometers without bending. So that is the things that we need for the space elevator, that kind of properties. No, that is the things that it is the active field of the research. It seems that each stars, and more generally a group of stars, they have their own chemistry. So that is the things that we see, and it seems that there are substantially different we have substantially different chemists in our universe. Each one, they have their own taste. Yes, the first thing that has been tried was the bombardment of the copper to gold, and I think the Enrico Fermi has done that in during the 1940s, before the atomic bomb has been basically invented. But generally, we now know that each of the elements in periodic table, they have their own applications. So basically, all of them are equal to gold for us. We can't have any one of them missed. Now, perhaps nanodiamonds are the very, very small bits of diamonds. So if you go to the jewelry shop, you see the big diamonds. You can take it as a pieces at the range of 10 to the minus 9 nanometer, which is 10 to the minus 9 is basically 1 nanometer size of the diamond. They are very, very small. And these are the things that we collected from meteorites. What is the application of that? We know that the diamond on Earth, they are the most strongest materials. But what is the application in the space? That is the open question for us. Now, the namings are proposed by the committee from the International Union and Union of Pure and Applied Chemistry. Before that, the name was the name of their cities or the name of the peoples which discovered them. But if I recall correctly, now they are called based on their atomic number, but in Latin word. For example, unil octium, like 118. It is like that.